Good day, good day, good day. Welcome back yet to another session. So today we are on day 15 of our random questions solutions, guys. So I'm having two questions focusing on probability. Enjoy. So for the first question, we are having this question shown here. It is saying let A and B be two events in a sample space, right? Suppose that the probability of A is equal to 0.4 and the probability of A or B equals to 0.7, and the said probability of B is equal to K. So it means that this is a variable, this is an unknown, right? So for the first question, they said, for what values of K are A and B mutually exclusive? So we are trying to find the probability of, the value of K for which these events are mutually exclusive. So how do we deal with this one? So for two events to be mutually exclusive, it means that they have to have no intersection in between. So it means that we are going to have something like this. So this will be A and this will be B. So there is no intersection in between. So we are going to say probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. So this is the general formula that we use in these probability questions. So it will mean that since probability of A and B, it is 0, right? Because they are mutually exclusive. So it means that this is just 0. So what is our probability of A? Our probability of A or B, it is 0.7. So we're going to put 0.7. And the probability of A being 0.4. And the probability of B being K. So it means that we are going to solve for K in that situation. So this can come this side. So it means that our K now becomes 0.7 minus 0.4, which just gives us 0.3, like that. So that's how we can solve this. We are solving for the unknown, right? So now the second question is saying, for what values of K are A and B independent? So now we are trying to find the value of K for which this situation is independent. So let me guide you through this. It's very simple. So for A and B to be independent, it means that our probability of A multiplied by the probability of B, we must get the probability of A and B, right? So what is our probability of A? It is 0.4 multiplied by the probability of B being K. It equals to probability of A and B. So this situation is the one that makes events independent. So two independent events means that the probability of A times the probability of B is equal to the probability of A and B. So now we can multiply out. So it means that our probability of A and B will be equal to 0.4 K, like that. So that's the first situation to our solution, right? But here we are just having a variable, right? We are trying to find this value of K. So again, we are going to use this golden rule again, which says that the probability, or let me just write it here, which says that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, like that. So here there is. So what is our probability of A or B? Our probability of A or B, it was given that it is 0.7. and the probability of A, it is given that it is 0.4, and the probability of B, it is given that it is K, and probability of A and B, we have solved it to be 0.4 K. So this will be plus 0.4, sorry, it's minus 0.4 K. So now it means that we can take this side, so 0.7 minus 0.4 is 0.3, because to K minus 0.4 K, it is just 0.6 K. So it means that now we can divide both sides by 0.6. It means that now our value of K, if we divide both sides by 0.6, it means that our K will be 0.5. So it means that if our events are independent, it means that our value of K becomes 0.5, like that. And if our events are mutually exclusive, it means that our value of K becomes 0.3, like that. Now let's move to the next question, or just let me just cut this video here, and then I'm going to create another video on the next question. So just wait for the other video and you watch it. So if you haven't subscribed, please subscribe, share, follow, like, and comment on what you're thinking about this. See you on the next one.